Welcome to another MyData Zurich webinar. My name is Peter James. I'm the co-lead of the MyData Zurich Hub. We are organizing events and webinars around topics such as human centricity, data privacy, and related topics. Today, Paul Knowles will tell us about a truly decentralized architecture, which will really help to implement data privacy. Let's get into it. Welcome to tonight's webinar of MyData Zurich. We are in a series of self-sovereign identity topics. We had one about identities a week ago. Today is about an example of the vaccination pass and distributed semantics, among other things. And there will be another one on May 20th, as you will see, about business models in this area. I'll quickly go through the MyData org introduction. I think most of you know the mydata.org logo, and it's basically a reminder that personal data is everywhere. And I just discussed it with our presenter before. I think even non-technical citizens are becoming aware that they should be careful with their data. This is the official depiction of the history with my personal remarks. So in the early days, we had a pretty API-centric approach. Everybody was communicating with everybody. Sometimes it did work, sometimes it didn't. So it was quite an interesting time. I usually call that the data stone age. Then came the time when the big tech companies started to run their servers, starting with Google, with Facebook, then Amazon and others. So I usually call that the data middle age. And the data was really on the servers of companies, and the perception at that time was that the data belongs to the organization which is running the server, which is obviously not quite right. So the latest development is now human-centric, and the data is actually owned by the individual, by the citizen. And I think that is going to be the future of how we deal with data. A few words about MyData Zurich. It's the four of us. André, unfortunately, he had to apologize for tonight. We just heard Pauline, and Daniela is usually quite busy at the university. And with myself, we started early 2019, and we are typically hosted by the Swiss Data Alliance, where we have a close cooperation. And normally, outside COVID, we are focusing on hands-on workshops. Unfortunately, that's not possible. So we are running webinars in a slightly different format, as you will see in a moment. As I already mentioned, we will have another one in our series of SSI, self-sovereign identity topics about data economy and data mart, if that is a contradiction. That they will be in German. It's a use case based on cars. It's my car dossier from Thies Löpfe. So it's mostly about business models. And then we have scheduled another one on September 16th. We had to reschedule this one more time. There are two reasons. One is we need to do that as an in-person meeting because we need to validate the identities. So we need to see the ID card. And the second reason is, as you certainly heard from the press, there's a number of delays in the rollout of the electronic health record. With that, I'm already introducing our guest presenter for today. It's Paul Knowles. He is the head of the advisory council of the Human Colossus Foundation. He will certainly say something about that in his presentation. He has more than 25 years of a track record in pharmaceutical and the healthcare sectors. Before I hand over, a quick agenda. So the format of the webinars is a 1 hour format. So we start with a short intro, as we have just completed. Then we have about 30 minutes of presentation, then some time for discussion and questions. And the official end is after 1 hour max. But the presenter will be available for more detailed questions for those who have still energy and are not yet too hungry. And just as a little commercial, mydata.org is a non-profit organization. For those who want to be involved a little bit closer, they can of course join. You can go to the website, you find much more information there. I don't want to make it too long for today. And with that, I can already hand over to our presenter. So first of all, many thanks, Paul, for taking the time for joining us, and I'm really looking forward to your presentation. The floor is yours.
Excellent, thank you, Peter. I will just share my screen. Good. Well, welcome to the webinar, everyone. Thanks for dialing in. Peter asked me to talk a little bit about the vaccination passports, which are obviously a very hot topic at the moment, but adding some distributed principles to what we're seeing and how we can evolve the space. Let me just move on. So as Peter mentioned, I'm the head of the advisory council at the Human Colossus Foundation. The Human Colossus Foundation is a non-profit foundation. We're based in Geneva, and really we work on very deep stack concepts and components for a decentralized and dynamic data economy, and really looking at three areas of decentralization. One for decentralized identity, one for decentralized semantics, and one for decentralized governance. And we really sit at the centroid point of all of those domains to try and help people understand the decentralized space, but also to help with real use cases and projects to help bootstrap their systems into the new economy and the direction that we're going in. There's a couple of other things I do in the space. So I'm the convener and lead of the Inputs and Semantics Working Group at Trust Over IP Foundation, and Trust Over IP Foundation is really it's a foundation that's under the Linux Foundation, where they're defining trust ecosystems with human accountability and cryptographic assurance, working between technology and governance across a 4-layer stack, right from utilities, right down from utilities at the first layer, right up to ecosystems at the 4th layer. We have a slightly different lens than the other groups. Our lens is more about the inputs domain versus the semantics domain, which basically means data entry versus data capture. And within our group, we have a bunch of task forces. So we go both horizontal and vertical. So the horizontal structure, we have things like a privacy and risk task force, a storage and portability task force, and a notice and consent task force. But we also have vertical structure as well. So we have a healthcare task force, and underneath that is like a fire focus group, for example. So that takes up a lot of time. I'm one of the conveners of MyData Health thematic group over at MyData Global. And then what's really interesting in the vaccine space, I'm also working for the Good Health Pass Collaborative, which is about 120 organizations behind that at the moment, and they're defining an entire process for vaccination credentials or travel passes, if you like. And my job for them is I lead the common data models and elements drafting group. And at the moment, all of that work has been, the initial drafting is all done, and that's gone for internal review. So that's kind of pretty soon I'll be able to share that with some of the people on the call. Okay, so first of all, I wanted to kind of explain what synergistic domains we need to look at when we talk about distributed systems or decentralization. And it's really these three, right? So you have three domains. You have the inputs domain, the semantic domain, and the governance domain. One is identity management, which we call the inputs domain. It's all about data entry and authentication. So you want to know that data has come from an authentic source. That's one domain. The other one is the semantic domain, and that's all about data capture. So you can think of traditional data management, and this is all about deterministic semantics. And deterministic basically means that you want to know that when you take a hash of content that when it's repeatable across a number of systems. So that's determinism. And then the last one is access management, and that's really about authorization and some of the rules behind access and exchange of data. So we call that the governance domain, and as I say, that's all about data exchange. And when we talk about vaccination passports, you need all three of these areas to be truly decentralized to stop a number of problems. And some of the passport solutions that are being deployed at the moment are not truly decentralized in a couple of these spaces, and that's where I envisage that there will be some initial teething issues, but hopefully through this webinar I can kind of show some of the technologies that I think could help alleviate some of those problems. So that's really kind of the broad scope of what I'm going to talk about here. So with these three domains, I thought, let's take a look at inputs and semantics domain. So you can think of those two domains as, we call them the data layer of a decentralized ecosystem. Data entry versus data capture, right? So, and here's the difference between those two terms. So in the inputs domain, we call it the active domain. Or the mail domain, if you like. It's what is put in, taken in, or operated on by any process or system. So the reason it's called an active domain is because the identifiers that are behind the activity in that domain are active state identifiers, which means that the identifier itself is controlled by an active entity. So that could be a human being or an active IoT device or something like that that can sign on its own behalf. So that's the inputs domain, and that's the inputs domain is all about identity management. All right, all about data, authentic data, if you like. And then there's the semantic domain, and the semantic domain is the passive domain. And the reason it's so this is the meaning and use of what is put in, taken in, or operated by any process or system. So you can think of things like, form filling and schema and all those sorts of things. That's where you add context and meaning to the data that's being inputted. And the reason it's called the passive domain is because the identifiers for identifying content is it doesn't have to be controlled by somebody. It's if you can think of a passport, right? If you take a hash of a passport, the passport itself is identified by a passive identifier, but it can still be controlled by an active state identifier, which is because you have the public-private key to control your own passport. So there is a kind of a linkage between the active and passive domain, but passive by itself is identified by content identifiers, if you like. Okay, so this is the inputs in the semantics domain. Just a very quick breakdown of some of the, you think of it as a yin-yang model, if you like, and some of the things in this space. So starting on the left there, where I say governing, that means that this is everything in the input side has the capacity to govern, all right? And on the semantic side, non-governing means it's entities or objects that do not have the capacity to govern. So that's the difference there. As I said, it's data entry. So data entry is about the typing things on your keyboard. That's data entry. But as soon as you type something on the keyboard, it needs to be captured somewhere to bring context and meaning to that, to the inputted data. So that's data capture. So that's the difference there. I've already mentioned active and passive, the active domain and the passive domain. And then I kind of do a little breakdown here of the individual elements within that. So where you'd have you talk about attributes in data management versus a claim on the input side. And a schema, which is a domain-specific data capture structure that's used to create a database record on the other side. So those two are persistent objects, if you like. And then finally, you've got the form and the credential. And we're going to talk about credentials a lot in this in this talk, a credential and a form. So you can think if you go into a post office, right, and you have someone gives you a form to fill in, you fill it all in and you sign it. As soon as you sign it, it's a credential, right? It's something that you can use to do something. So it's a transient object. It's not a persistent object. You can think of persistent objects as database records and transient objects as credentials of stuff that's transient that you can use to activate an activity, if you like. And then the two characteristics between inputs and semantics in identity management, it's all about authenticity. You know, has this data come from an authentic source? And then in the semantic domain, it's deterministic data, or deterministic content. So you want to know that this hash of this content, wherever it ends up in the world, on Mars, Jupiter, doesn't matter, it's always going to be exactly the same content. So that's deterministic. And the reason I bring these terms in is that you may have heard a lot of people talking about immutable data and stuff. And the problem with immutable is great for things like time stamping, right? Where you want a log of a transactional activity over the life cycle of an identifier. Very useful for time stamping and mutability, but not so good for data, because when you talk about data, you don't want it to be immutable, because you, as the controller of that data, you want to have the control to be able to remove or revoke or delete data or schema that you've created on your own terms. So that's why we use deterministic, not immutable, when we talk about data. My expertise is in semantics, so I'm going to talk a little bit about that. I've been, as Peter mentioned at the start, I've been working with clinical trials for 25 years, and always in data management, both for the data capture structures, but also doing analytics and stuff on data. So I've kind of worked in both of those spaces. So in the semantic domain, a schema is a machine readable definition of the semantics of a domain-specific data structure. And there's a technology that we've invented at the Human Colossus Foundation called overlays capture architecture. And this is now getting a lot of attention as an architecture to enable true interoperability of data capture objects within a decentralized and dynamic data economy. So this is what the architecture looks like as a schematic. So OCA is an architecture that presents a schema as a multi-dimensional object consisting of a stable capture base down the bottom there and interoperable overlays. Overlays are task-oriented linked data objects that provide additional extensions, coloration, and functionality to the schema to the capture base. I need to change that word. So basically, with these objects, I'll show you exactly what all of them do. So a capture base is just a structure that gives you, that's where you put all your attribute names and your types. But the important thing in a capture base is you as an issuer can also flag any of those attributes as being personally identifiable information. So right as soon as you create it, you can flag stuff right off the bat. And that's really important to do at the first stage of the life cycle. It just means that any information that's being dragged through this capture structure, that information is already flagged. So wherever it goes out in a distributed or ecosystem, you can always you always know that you have to do something with it, whether you want to do some masking to it or some sort of encryption. We don't define that in the architecture, but at least you know it's flagged and you have to do something with it. The meta overlay is things like the name of the schema or the description of the schema. A lot of the schema in today's world is written in English, right? The description is in English, etc. By having a separate layer here, the meta overlay, it just means that you can put the description of the schema in any language. So it could be English or German or Chinese. Because it's a linked object, you can just swap that in as you wish. A character encoding overlay is where you set your character encoding. So usually it's UTF-8, but if you wanted to use US ASCII or something like that, you can separate that from the capture base using a character set encoding overlay. A format overlay for things like date formats, for example. You could use a format overlay for that. Entry overlay for predefined entries. So you can think of in a field where you have gender, for instance, you could have male, female, undifferentiated. Those are predefined entries. With an entry overlay, you can have multiple entry overlays in different languages. So you could have exactly the same predefined entries in, again, German, Chinese, whatever you want. The label overlay is about human readable labels and category labels. Again, it has that language option on it, so you can do it in multi-languages. And the last one there is an information overlay. And the information overlay is like where you do your, where you have some entry hints or something for the entry process. So again, that can be written in multiple languages. So this is a really powerful architecture because it right from the start of the data ingestion, you already have this interoperable structure that people with similar use cases can use and kind of tweak it for their own language, if you like, right? And I mentioned in the capture base there, you can flag attributes. And we have this blinding identity taxonomy, which is it's a taxonomy of 49 elements that is now being donated to the Kantara initiative for elements that should be flagged as personally identifiable information. So there's a couple of elements in here that you should probably be aware of. Obviously, there's things like right down the bottom there, free-form text fields, unstructured data. We don't like free-form text fields in data management because they're a risk, because we don't know what people are entering in those fields. So when you issue a schema and it's a free-form text field, you should automatically flag that as being PII. The other one to look at is things like dates and timestamps. I've said if you're unsure about a date or a timestamp, then flag it. Sometimes those dates and timestamps are useful, and they might be. You might need them not to be a PII, but if in doubt, flag it. So anyway, this is a taxonomy that you can use, that an issuer can use to flag any attributes that are PII. So I just wanted to kind of show you how this overlay structure looks like as a representation. So this is a typical demographics form from a clinical trial, right? So all of the big pharma companies would use this sort of form for the demographics domain, so to create a schema around that. So on this form here, you'll see that they've got date of birth, right? That's personally identifiable information. So you want to flag that. So breaking it down into those layers, because some of the what you've got at the top there, that's actually would be held actually in the meta overlay, not in the schema base. This is an old slide. I do need to change that, but that would be in the meta overlay. You've got then everything is layers on top of that. So all of your human readable labels there on the left, that's a label overlay. All of your predefined entries on the right, that's an entry overlay. And I will just go down. So this is a slightly different representation of the same form. This is more of a techie form, if you like, what the coders want to see. And in this form, again, you've got some of the meta information would be in a meta overlay. Your attribute names there held in the capture base, and then moving on again, you've got the format overlay. So that's where you do your date formats and some of your lengths, if you like. And then an entry overlay for your predefined entries. So I just wanted to kind of just show you that so you could get a kind of a bit more of a visual representation on what we're trying to do with overlays. And this is again a visual on why it's important. So if you think about object interoperability within an industry sector, say that demographics form has been issued by Roche, right? A good Swiss company headquartered in Basel. So they've created this demographics schema with all these overlays, and they've got a classification code there, which is a global industry classification sector. There's a code there. With that code, you know that it's the high level code is healthcare. It goes right down to pharmaceuticals. So if we get in the habit of kind of tagging all of these structures, it becomes quite easy to find them. You know, has this schema come from the financial industry, or has this come from the pharmaceutical sector? That sort of thing. So we have that option in the meta overlay to be able to put in a tag code. But this is really what I wanted to show you. So say Roche has built that structure, and then Novartis comes along and they say, that's a great structure, but we want to add some predefined entries to a couple of the attributes. Rather than rebuild the whole schema and have that duplication, if you like, in a decentralized system, they can just take out the entry overlay and put their own one in, right? So now Novartis are using their own predefined entries on the same schema structure. And then maybe Pfizer comes along and says, oh, we just need to change some of the labels. We want to put them in Chinese because we're doing a Chinese clinical trial, for instance. They can just pull out the English language one, put in the Chinese language one, and then they're in the stack. And then maybe GSK comes along and says, great structure, but we only want 3 attributes from that schema. They can just take a subset overlay, put that in, and then they can use the same structure. So you see in all of this movement, the schema base or the capture base, it hasn't changed. That's remained stable the whole time. But now you've got 4 companies using the same structure in this visualization. So what I wanted to do there was quickly show you what an OCA form looks like for real. So this is a yellow fever vaccination report at this. Right now is in English. You can see that all of your human readable labels and all of your information is all in English. Your predefined entries, male, female, they're all in English. But then because we've got this overlays going on, I could change this to German and it just pulls in a bunch of German overlays onto this, right? So now everything is in German. So all your human readable labels or your category labels, they're all in German. All your information's German, and all of your predefined entries are in German, right? And you could do this in 65 languages. We've got here Spanish, we've got French, you know, whatever you want. But it's all the same schema base. And that's really important, because when you want to aggregate data, because the schema base is stable, it just means that when you go to push that data for aggregation, for machine learning and all that sort of stuff, the data will knit together really well. So I'm just going to stop sharing there again. I just wanted to, I always find it's easier to actually see these things in action sometimes rather than off a schematic. I'm just going to stop sharing there. Okay, so that's OCA. So OCA is an interesting one in the decentralized semantics space. So that's a properly decentralized solution for a distributed economy. And then I haven't gone too deeply into the inputs domain, because that's more about SSI and I think a lot of people on this call probably know a little bit about SSI. So SSI traditionally is from the identity space. So I thought inputs is kind of done. The semantic space, I've kind of been through that. The next thing to think about is the decentralized governance. And this is really important. And the governance, the rules domain, right? So this is the rules for what is accessed, exchanged, or operated on by any process or system. So if you think of the 3 domains, one is what is being inputted into the system. That's identity management. The context and meaning around the data that's been inputted is data capture. That's the semantics domain. And then this is the governance domain. This is the rules for what is accessed and exchanged or operated on. And I'll just quickly, so this is I'm now going to show you a vaccination, what we call the digital immunization passport, which is an EU funded project that we worked on with Own Your Data, which is an Austrian foundation. So Christoph Fabianek, the head of that foundation, is he's actually on the board of MyData Global. So we worked with him on this solution, Human Colossus and them. And this is just an end-to-end flow. So the governance has become super important here, because you're working with a number of different actors. And so all of that work needs to also be decentralized. There's a couple of components here that I will quickly mention, and then I'll show you the video of the solution. So there's two things to look at on the container side. So one is one's a data vault, and a data vault you can think of as a persistent or a permanent store of personal data. So that would be something that would be held by me as a citizen, right? A citizen, I hold my own data. That's a data vault. But then you've also got a semantic container, and a semantic container is a little bit different in that it's where you can hold data that is transient. And this is a really important technology, because when the identity community talk about a credential, they're talking about zero knowledge proofs in the actual credential, and the credential is used to transfer information between two parties. But it's not a credential isn't very good for something like clinical trial data, for instance, where you have a lot of data. You can't put it all in a credential, right? What you want to do is put it all in a semantic container or a solid pod or an open data sharing unit. They're all the same thing in my head. They're all transient containers. But you can put all sorts of things in there, right? You can put in, PDFs. You can put in terms and conditions policies. You can put it whatever you want in a semantic container. And the interesting thing is then you can use a credential, and a credential is what you can use as a proof of that you are the authentic source for the data. So you can say, in this semantic container, I'm coupling this credential to the container, and I'm saying with that, I'm signing it, and I'm saying that everything in that container is authenticated by me as the citizen. So those are two objects, and the last one here is called a trusted digital assistant. And a trusted digital assistant, you can think of it as an API plugin gateway for a citizen, so that they can interact into a distributed and dynamic data economy. And what it is something that it's not held on a node on a network. It's held as a component on your personal device. And at the moment, you'll hear a lot of people talking about networks and blockchains and stuff. But it's not very good for a vaccination passport, because what you can imagine that me as a British citizen, if I go to Heathrow Airport and I want to, and I'm traveling to China, I need to know that the whole solution will work both in the UK and in China. But what if they're using two different networks? And that's the point here. It's very difficult for the two networks to talk to each other with current technology. And because if your root of trust is a node on a network, then you're caught in this kind of network lock-in situation. So it's fine if I want to kind of transact or communicate within that network, but as soon as I cross networks, then you have a problem. Whereas with the trusted digital assistant, because it's a component on your mobile device, the root of trust is with you as the human being. And then it doesn't matter what system they have their credentialing system on, because you can interact with any of them, because you're not locked into a specific network. So as you can see, we're starting to get truly decentralized with this solution. So on that note, I'm just going to stop sharing again, and I will I will actually run a video for you, this digital immunization passport demo. This is a short demo describing the technical components that have been developed during the first phase of the NGI-DAPC Digital Immunization Passport project. During the course of the project, the team focused on further developing the following three components. Semantic containers are a solution for data mobility. The component has been extended to include a standardized and fully documented API for data exchange, as well as incorporating all of the necessary functions required by participating actors in a single container. The Own Your Data Data Vault is a personal data store that has been extended with an API to enable the aforementioned standardized data exchange. Additionally, the team has implemented digital watermarking for unambiguous tracing of shared data. Finally, the Trusted Digital Assistant, a component developed by the Human Colossus Foundation, is the user interface for credential exchange, which is built upon Hyperledger Aries technology. It also handles multi-language form inputs through the overlays capture architecture. For the first data flow, we demonstrate creating a verifiable credential for a yellow fever vaccination. This requires the user to establish a connection with the doctor, provide the necessary information for onboarding, and the doctor confirming the vaccination has been performed. Here we see the trusted digital assistant of a user. A connection is established by scanning a QR code that has been issued by a clinic. As soon as the connection has been established, the user is able to review the services provided by the clinic. The user fills out the required information and confirms by clicking Apply. The information is transferred to the clinic, shown here on a tablet. The doctor reviews the information provided and confirms the vaccination. Switching back to the user's device, the new verified credential is displayed in the My Documents section. From a data perspective, this workflow has shown a doctor's office receiving data about the user's vaccination request and a verifiable credential being stored in the semantic container. The usage policy from the doctor and the verified proof of the vaccination are held in the user's personal data store. In the second data flow, we demonstrate a customs officer receiving a vaccination credential for the purpose of granting the user entry clearance into a country at the port of entry. This requires the user to establish a connection with the customs officer. The user then reviews the usage policy for border control requirements and provides a verifiable presentation to the officer, who can then verify the information and decide whether or not the user can pass through immigration. Here we see the officer's trusted digital assistant capturing the QR code stored on the user's device. The officer then selects the proof of vaccination credential type from a drop-down list and sends the user a request for the verified credential. Switching back to the user's device, an incoming notification from the officer is received. The user accepts the request and shares the credential with the officer. An incoming auto-filled verifiable presentation from the user is displayed on the officer's side, and the user is granted entry clearance into the country. The user receives two assets. Firstly, a document confirming that they have been granted entry clearance, and secondly, a dedicated verifiable credential which links back to the presentation and the original credential. From a data perspective, this workflow has shown the provision of a verifiable presentation from the user to an officer at a point of entry, and the officer to then be able to issue a credential to either grant or deny entry clearance to the user. The usage policy from the officer and the verifiable credential for entry clearance, including all linked information, are held in the user's personal data store for full traceability. In the final data flow, we demonstrate how individuals can share personal data in a secure and traceable way with other requesting parties. In this flow, we assume that an organization has invited participants to take part in a survey via email. The user can review the invitation request, fill out the survey, and attach time series data from their personal data store. Finally, we show how a user can manage that shared data. Here we see an email sent from a semantic container inviting the user and other participants to take part in a survey. The user clicks the link and connects to a personal data store plugin, which displays an overview of the information. The survey is then auto-filled from previously stored data contained in the user's personal data store. A user can also add time series data to the completed survey. This data is watermarked for the purpose of unambiguous tracing. The user then reviews the data and sends the completed survey to the semantic container of the requesting organization. The user's personal data store also provides a plugin to manage consent information. All consent receipts provided by semantic containers, for example, can be listed along with selectable service endpoints and associated usage policies. From a data perspective, this workflow demonstrates how a requesting organization can benefit from an encapsulated process to retrieve personal data from consenting users while fulfilling all jurisdictional privacy requirements. The usage policy from the organization, a digital fingerprint to identify the shared data payload, and mechanisms to trace data usage and revoke consent are all held in the user's personal data store. I know there's quite a lot of information there to probably absorb as well. So I think people would probably like to take it offline and go through it slowly and see how that works. But hopefully you got the gist of it. It's basically, the citizen is the citizen is at the front and center of everything. So they're in charge. They're in charge of their data. They're in charge of the consent. They're in charge of their TDA, their trusted digital assistant. So they own the hardware and the software. And when you transport sensitive data between parties, it's not all held in a verifiable credential. It's held in a semantic container, which has been using a credential you couple a credential to it and you sign that as a method of authentication. So this is it's a nice solution. It's not quite ready to be deployed out in the world, but it's it's a great start, and I think it shows people the direction that we're going in a decentralized space, and maybe the next generation of vaccination passports will be this decentralized. That's what we envisage. It's just right now it's quite difficult because some of the technologies are not really that mature to be able to get a truly decentralized vaccination passport. So I think there will be some hiccups with some of the early deployments. Certainly, I think there's going to be a governance issue because they're all working off different networks. I can imagine that will be a problem. But yeah, and obviously the semantics, OCA is a relatively new technology. And then the last one for the identity piece, there's a new technology being developed called Key Event Receipt Infrastructure, called KERI. And KERI is quite interesting because it's not reliant on a blockchain, but it still has all the cryptography built into it to give you a solid root of authenticity. But because you're not dependent on the ledger, you can lock that to a component on your device. And so those sorts of technologies will all need to become a little bit more mature over the next few months. But once they're in place, then we should be able to get a truly decentralized solution for a vaccination passport. Sorry. Yeah.
Very good. So I think just looking for, time is ticking. Still room for a few questions. I have actually a first one. You mentioned that the technology is not yet quite mature. Could you say something? What's your view on a potential migration path? So we have to start with something today, obviously, as we are under time pressure, and maybe in 1 or 2 or 3 years, then we have let's say more state-of-the-art technology. That's part one of the question. And the part two, I'm hearing there are certain initiatives to link the vaccination to the technology which is available from the credit card companies, Visa and so on. So if you know something about these projects, that would be interesting.
Yeah, so of the two questions, so the first question is really about technological maturity on some of these things, and maybe a solution if you're deploying as of today. So if you're deploying today, my suggestion would be to look at Hyperledger Indy, Hyperledger Aries, those technologies which are SSI technologies. So people on this call may have heard of the Sovereign Foundation. The Sovereign's network is built on Hyperledger Indy technology, and that's pretty robust. So that would be a good one to start working with. Yeah, that's probably your only good option, I'd say, at the moment. It's the only really the one I think that I would consider stable in a decentralized space. Your other question was to do with yes, some of the big collaborative projects that are happening at the moment in this space. So I can talk firsthand of the Good Health Pass collaborative. So that's a collaborative with I think about 120 organizations at the moment. They include a whole bunch of solutions for vaccination passports, but they also include some of the big companies like Accenture and MasterCard is in there, and some of the airline consortiums are part of that as well. So I believe IATA is in there, and ICAO, all those sorts of organizations. But really, what they're trying to do is come up together, build a whole, a bunch of drafts that they can use as a solid package for how to go about deploying a solution out in the wild. So because there's a lot to think about, right, in this space. So you've got rules engines, you've got trusted registries, you have common data models, you have obviously semantics technologies, you have decentralized identity technologies, you have it goes on and on, governance things that you need to look at. So there's a whole bunch of things to look at, but within all of these 9 drafting groups they've got the expertise to try and pull together some sort of package to say this is what we recommend, and actually we're also writing a technical implementation guide for how to do it as well. So within that space, the common data model that they're using is FHIR. So HL7 FHIR, which is really used for electronic health record information. And in that space, and the reason we've gone with that data model is because that's what the EU has specified as the one that they would recommend, but also the World Health Organization has as well. So that made it an easy decision. But we also, FHIR is not an easy data model to work with. It's a very nested data model. And because of that, we've built a transformation pipeline so that you can ingest FHIR into the transformation pipeline. It kind of unravels all of that and gets it in a very simple, it puts into very simple OCA structures. And from that stage, you can start credentialing. Once you've got it into OCA format, it's very good for credentialing because then you have all of the multilingual, multi-language options. So that when you resolve the credentials at the user side, you can quickly swap between languages. So for instance, if I was traveling to China, they might have some Chinese overlays that they can use on their side to automatically translate your credential. So you might write it in German, but they might want to translate it in Chinese. So that's why OCA is quite a really interesting technology. But yeah, so all of that, we're going to build all of that into an implementation guide, and hopefully that'll go out. So the timelines for that, we have a 30-day timeline for kind of initially drafting all this stuff. Then there's a 90 days and 180 days. And by the end of the 180 days, they want to have it so that it's a proper enterprise-worthy solution to be deployed. So yeah, I don't know if we're behind the 8 ball with the timing of all this stuff. Sometimes it feels like we might be late. I don't know how long this pandemic's going to go on for, but the good news, I think, is it's not just about this pandemic. The more important thing for me is that it can prove that you've got a safe and secure way to share data between 2 people, and that to me is the most important thing through all of this. So to me it's a little bit of a smokescreen perhaps, but I think there's some really good intent behind it, which will be fantastic for the next generation dynamic data economy.
Thanks a lot. So that was just a comment. There is also the next pandemic. So for this one, hopefully we are ready.
We should be good.
I don't hope so. Using the last few minutes for questions, you can either raise your hand. Oh, there's actually somebody raising the hand already. It's Philip. Philip is actually joining us. Philip, go ahead.
So actually, it's more a comment than a question. You asked, Peter, whether we knew about the connection between a credit card and the vaccine credential. And there is something which is in this talk we spoke about immunization passport, not vaccine credential. Because everything that is taking place now is about passing a vaccine credential or a test credential. If you want to speak about immunization, this is not only about one credential. You have to have a multi-factor. You have many factors entering into the notion of immunization. So the point I'm mentioning here is today, every solution we have seen, and we are aware of some of the big one, like working with IBM and also the people that are part of this Good Health Pass, but it's really a lot about passing a number of credentials. If you want to speak about immunization, you are touching the electronic health record of the patient because you have to be contextual to the patient. And this is where the current passport or certificate, they don't call it passport anymore, actually. They call it more digital certificate because you can't actually bring all that data to a centralized authentication system or part of a big platform, because then you will have to open the whole health data of the patient to this because it's really contextual. So that's the first distinction. And the reason you need these two decentralization of the authentication and of the semantic. The semantic is actually available now and it is being used, but the authentication is about really the identity of the patient. And in the graph show use data flows, you could see that the identification we used into this DIP was using a standard one. It was, since we worked with an Austrian foundation, they use an IDAS compatible identification, which means that this digital ID that the person will carry when it goes through a border, they need simply to be connected with any IDAS compatible system. And we also use, we are now implementing a biometric identification. Yeah, if you see here, it's up on the upper left corner. Now, the current situation, every solution of digital certificates we know are using a platform. I would say the best one will be using a decentralized blockchain just made for identification, which preserves pretty well the privacy of the user. But other blockchains are being used. Some were not specifically designed for digital identity. So then you have to rely in the trust of the implementer of the solution that your digital identity and your medical data or your credential are not being mixed. And that's where the self-sovereign identity plays a big role, because if you can't really control this digital identity, you might see platforms that start to concentrate your medical data with some other data that are needed for traveling, like your passport data, your name and these things. And this is the current situation in terms of the passport we see on the market. The one that will be developed in Switzerland or in Europe are not really using SSI. So they have a certain limitation in the actual number of credentials, in number of information they will be able to pass, if we don't want them to recreate a health database held we don't know where, because actually this data will have somehow to travel to the destination you will want to use this passport.
Okay, thanks, Philip. So maybe the audience is a little bit overwhelmed. I appreciate it. It was a lot of information. It was maybe sometimes a little bit abstract. That's why we discussed in advance that the live demo would be helpful, because it shows a little bit how this works. So as there are no more questions for the moment, I'm coming to a close, but nevertheless, I want to make an announcement, because while I was waiting with Paul, we just discussed this Good Health project, and we already agreed there will be another webinar on 10th of June, 6:30 p.m., where we will introduce a little bit more the activities of this Good Health collaboration initiative. And it's based, it's basically the health data of the respective persons. It's a huge initiative, as we already heard, and we are trying to invite some other presenters who are very close to this topic. So maybe for those who are not so close to the health activities in Switzerland, we are in the middle of standardizing our activities and our data standards here. So we have the electronic health record in Switzerland, which is currently more PDF oriented, but eventually will move into more structured data. So there are some activities in progress now, and there are some other initiatives. One is HealthLink, which is a little bit complementary to the electronic health record. And we just agreed in the last few weeks to base on the same standards and to avoid some more silos going forward for more interoperability. So again, on June 10th, 6:30 p.m., we will have another webinar which will really focus on this patient-oriented data, which is based on FHIR, obviously, as we heard today. So, with that announcement, a last chance for questions in the official part. Still overwhelmed, so then I'm inclined to close the official part. Thank you very much, Paul, for providing all this really interesting information. Also, Philip for chipping in.